everyone. Thank you for joining today's session. We're sorry we started late. We had some technical issues, but we are ready to dive right in. Today, we are talking about deploying infrastructure using Azure Pipeline or deploying CI/CD using pipelines. And with us today to teach on that is Mr. Imo. He'll be teaching us on that. So we'll get right into it, not to waste more time. Mr. Imo is a senior cloud engineer and he has a lot of years of experience working on the cloud and even DevOps itself. So is in the best position to take this topic, and I hope you enjoy it as we go on. Mr. Imo, thank you for doing this today.
All right, thank you very much, Dami, for having me.
Yeah, welcome,
Um,
sir.
Before I move on, please quickly confirm my audio. Dami, can you confirm my audio for me? Is my audio fine? All right. So, good evening, good morning, good afternoon to the audience from wherever you're joining us from. So today we are going to be looking at deploying infrastructure as code with CI/CD pipelines and exploring in the context of Azure pipelines, a component of Azure DevOps. Um, Before Damilola has already done justice by introducing me. My name is Imoetuk, and I will be taking you on this topic. So let's carry on. Um, Before I move on, we have been hearing of infrastructure as code and CI/CD pipelines. But a lot of you might maybe ask question, what is it all about and what is all this? So one thing you need to know is that with CI/CD, with the ISC, that is infrastructure as code, you can easily organize the way you want to define your infrastructure. You can define it in a way that you can easily control each of the version you roll out on each of your software lifecycle management and interface. You can also it also in one of the tools that enable you to manage your code automatically, thereby making you to reduce some of the errors. Infrastructure as code is commonly referred to as immutable, meaning it cannot be changed easily. You can only destroy the current code and then deploy a new one. And that helps us to check the vulnerability that could exist in our code deployment. Meaning you cannot modify an already code that's been under attack or that has a bug. You can only destroy that and then redeploy it with a fresh code. So having it on the screen, what is infrastructure as code? Infrastructure as code is a process of managing and provisioning infrastructure using machine-readable definition files instead of manual configuration. The key term there is that manual configuration is eliminated. You don't have to make errors. It takes away that human errors in the process of deploying our code. It allows us to build, change, and manage your infrastructure as a safe, consistent, and repeatable way by defining resource configuration that you can version, reuse, and share. One good the good part of it is that with infrastructure as code, one of the key example, one of the leading infrastructure as code is Terraform, is a cloud agnostic and an open source um, tool that you can use. Is that you can easily repeat that code that you have templatized. If for instance you have defined an infrastructure as code to deploy maybe Azure virtual machine, that is to run in your Microsoft Azure cloud platform. And tomorrow you want to deploy that same machine with the same specification, you don't have to start all over writing your code. You can easily pick up the one you have already defined and use. That makes it reusable, and you can easily share it with other people to use it. So today, let's dive into the benefits that you can gain when using infrastructure as code. So some of the benefits are you can easily version your code. That brings in the concept of version control. In this case, infrastructure divination can be version control, and which provides traceability in terms of an accountability for infrastructure changes. All the changes that are made to your infrastructure can be traced, it can be tracked, and you can mirror it down to be able to detect where there is drift or error in the process of deploying your code. Version control systems enable you to see who made changes, just as a lot of you have been using maybe GitHub or Azure Repo and GitLab and all that, managing your code. You'll be able to see each of the version, each of the changes made, and all that. So it makes also it introduces the concept of consistency and reusability. It makes it easy for you to reuse your code, and component like I mentioned of Azure virtual machines, it can be used on premises as well. You can use it to also templatize your infrastructure on premises, and also on the on and also you can also use it for your cloud as well. You can use it for database, you can use it to define your databases, your virtual networks, and anything you can think of as far as that stuff is infrastructure. So it helps you to reduce duplication of effort and increase efficiency. Efficiency is the key benefit here. It brings in about that. So consistency is that infrastructure divination can be tested and validated before deployment. Terraform helps you in this case, ISC2 helps you to ensure that each of the stages are being validated before moving to deployment, which ensures consistency in the environment that you are deploying your code to, your infrastructure code. So now it helps to prevent manual configuration, thereby reducing errors for you. And we also have now the core concept we are going to also discuss will be Azure pipelines. First of all, what is Azure pipelines? Azure Pipelines is a cloud-based service by Microsoft, a component of Azure DevOps. Azure DevOps is a software as a service platform that enables you to automate your DevOps, your CI/CD deployment using the component called Azure Pipelines. So now it's owned by Microsoft. That it helps you to automatically deploy, build and test your code project. It combines the concept of continuous integration and continuous delivery, and to build, test and deliver your code to the market. For instance, I'll be using my own tool right now. So if you want to deploy, let's say we have a developer somewhere who is the person writing the code, and of course he's doing that in his from his computer. This is a developer. Now what he does is he will pick up the code. Once he pick up the code, he will move down to, he will deploy it to where? It will push his code from here. This is your from your source, which is your computer, your local environment. It will deploy the code to Git any version control system using the Git tool, which comes in here, using the git push command to push the code there. Before getting to the git push command, of course, we know that he or she must have used the git init to initialize the project directory, and also git add to add the project files to the directory. Then use git commit to commit those changes before pushing it. So these are the commands that will be used at this point to manage that versioning of your code and all that. So now git push will take the code down to Azure Repo. In this case, we want to talk of Azure Repo. we are not Azure Repo. We are not using a GitHub because we are actually dealing with what's it called? We are dealing with Azure DevOps. Azure Repo is similar to GitHub version control, but is under Azure DevOps. So now in this place, we are storing our code in Azure Repo, and we are talking about ISA, and Terraform is what we are using. In this case, the developer is simply pushing Terraform code to the Azure Repo, and now there will be a trigger at this point. This trigger will be able to trigger the build process with Azure using Azure pipelines. Adding trigger will make sure that there is a build process that automatically starts, and will be controlled by Azure pipelines. And this place that will come in here. So Azure pipeline will be here. Now, what Azure pipeline will do in this case, is going to deploy this code using Terraform, of course. And what Terraform does is it will validate this code. For Terraform to validate the code, it ensures that it actually meets some criteria. It will initialize that code. After that, it will validate to ensure that the code actually it's free of issues like bug or any drift that could be detected at the early stage of the configuration management process. So it will be able to deploy it without errors at the end of the day. So this is what Terraform will do. And in this place, we are dealing with now come to this place to Terraform at this point, because the YAML file we are going to define will be defined based on Terraform extension, Terraform syntax. So at this point, we have what is called YAML file that has come in here. You can call it TF. TF is actually the extension for identifying Terraform files. Terraform, when a file is named as .tf, is actually Terraform. So now we have a YAML file here. I'll name it pipelines.yaml. So at this point, this will configure, this file is going to contain all the configuration steps, ranging from where the environment to deploy to where to deploy from, and all that. It has to do with it will also contain some service principle that you define, because on Microsoft Azure or Microsoft Azure environment as a whole, you cannot deploy when you're deploying maybe application infrastructure or code using a tool like Terraform. It's a third-party tool. You need to create your service principle. You need to bring in that service principle and also create the client secret and all that. So for you to do that, I'm going to take us through that later in the course. So now we have the Terraform, the pipeline.yaml file that once you create the Azure pipelines to automatically generate your pipeline.yaml file for you, just for you to make some changes by adding your service principal details such as client ID, subscription ID, client secret, and application ID as well. So what it does after that, you just trigger the build, and it will build into Terraform will help to validate it, and after that it will run the Terraform plan to ensure that everything is in place. And after that, what it does will be to build that process for us, to build the code. After building it, what it does at this stage is going to apply whatever we have defined in this Terraform. It's going to apply to apply and actually deploy whatever you have put in place. So now this is how it will apply the changes and actually deploy the infrastructure. So now at this stage, we can see that our infrastructure is ready. Assuming we want to deploy maybe Azure App Service, or maybe Azure EKS, Azure Kubernetes Service, or anything at all. At this point, the infrastructure will be ready to be used. I will just say infrastructure is ready to be used, so you can use. In the process of deploying this thing, a lot of things will go into play. You have to, as I explained before, you have to create Azure DevOps organization, create a project within that Azure DevOps organization. After that, you have to get your Terraform code ready, and that will be managed by the developer. It could be you and me who manage that. That comes from the source. Make your commit, make your init, and also commit changes, and then push it to Azure repo. Then initiate a trigger that creates Azure pipelines. At this point, a YAML file will be generated, and then Terraform will pick it up by validating those YAML files, the steps that are there. If they are okay, if they are free of errors, it will just deploy. It will plan it, then build, and then apply. And then you see that our infrastructure will be ready in seconds. So one of the best practices for you to do is always check. One of the things the pipeline, Azure pipeline can help us do is that it will help us to check errors at the early stage of the deployment or of the integration of the continuous integration stage before things pass to the deployment stage. So this is a very, very good way of getting it done. So let's go back to our slide, come back to this later. So now, as you can see in the example diagram I have here, we have our code today. This is assumed that our code is in the GitHub repository, but in the whiteboarding I just did, we are having our code to be in Azure repo. Then Azure pipeline will build that, and then it will also handle the release process. But in this case, Terraform will handle that by building and releasing it to us. So then it can deploy to Azure Function. Azure Function is a serverless company. Can deploy it to maybe infrastructure on Microsoft Azure or any other cloud provider, if not Azure. So now we have that. So now tools and components required for this process. As I said before, you need to have Azure DevOps, which will serve as the version control system in this case. You need to have you need to also have Azure DevOps pipelines for the CI/CD that will serve as the CI/CD tool in this case. Remember, we have other CI/CD tools like we have Jenkins, we have CycleCI, which are also available. But in this case, Azure Pipeline is also a CI/CD tool I can use. Then we need to get Terraform as the infrastructure as a code tool. We also have other infrastructure as a code tool. We have Azure Resource Management tool. We also have Azure Bicep, and we also have other ones. But in this case, Terraform is an open source and cloud agnostic infrastructure as code tool, and that meaning you can work across all cloud platforms, irrespective of whether it's Microsoft, whether it's AWS or Google. So now you have you have to have Azure Cloud as the cloud service provider. In this case, you have to have that, and you also have an active subscription. In case you do not have Azure subscription, you can sign up for free. The moderator will help us to put the link. You can sign up for free and get started. You can just easily try out how to use it and all that. So another one is you also need to have the service principal. You need to have Azure Remote Backend for Terraform. Azure Remote Backend in this case, and use it to store the state files, which contains some critical information. Usually use Azure Storage in this case, or I can use you can also use Azure Container Registry to store it to ensure that it is secured. So moving forward, now what does it mean to deploy Terraform using Azure DevOps? That's what we're going to look at now. So now, what it means is that Azure DevOps will help you to do to validate, as I said before. Validation means it simply check to ensure that there's no errors before deploying. You test it as well. So now plan simply means that Terraform will have to plan all those. Here the execution plan will be defined. It gives us opportunity to check for any noticeable infrastructure changes before deploying, before publishing maybe an artifact or building it. So now in the build stage is where you generate, this is generated by the pipeline, and it gives us the file itself that we're going to deploy. Now it will also do us a favor by deploying and releasing it. When you use Azure pipelines, Azure pipeline job will trigger the deployment each time an artifact is published to trigger it and probably then release it to and make it for use. So that these are what it takes to actually deploy Terraform using Azure DevOps. And now moving forward, steps that are involved in this thing we are doing and we are going to do today. Steps that are involved is that you must have an Azure DevOps organization. You must have created one, log into it, and then create a project within it. Project can be either public or private. It is public when you want anybody within your organization to have access to it without being invited. It is private when you have some selected project owners or people you want them to be part of that project, and you select some group of people, and then maybe send people notification or invitation to join that project. That's when a project is private. Now, another thing you need to do is to go to your pipelines and then select your new pipelines, do the steps of the wizard, follow through the flow process, so that your Azure DevOps repo, in this case, is served as the source code repository. That's where your code lives, your code stays, where you have put your code from your local computer up there. So now, when you see the list of repositories, select the one you have already defined, your repository. Of course, you know it. So that's going to be the flow. So we have come to the end of the slide presentation. Let's jump into the Azure DevOps environment. So now I am right in my Azure DevOps environment. This is where you have, I'm going to go back for the sake of those who have not have access to, or who does not even know anything about Azure DevOps. So Azure DevOps, as I said, is a software as a service, falls under like GitHub and all that, offered by Microsoft. And within it, we have components like projects. You have Azure DevOps organization. You can have many organizations within a single account. As you can see, I have 1, 2, 3, 4 organizations. And also there's one more, 1, 2, 3, 4, 5 here. You can also, each of the organizations can have different projects. I have one project within my test lab project 1. I can as well create a new project if I wish. But for now, I'm going to be working with this test project. This is where my code, my Terraform code is reside. Now, what you're going to do before you can deploy using Terraform in the Microsoft Azure environment, as I said before, you need to create a service principal. That service principal will act on your behalf to allow that deployment to go through. So to do that, because of the security of my credentials, I'm not going to expose a lot of things, because if I do that, I will have my subscription ID, I'll have my app ID, and anybody that lay his or her hands on these details can easily hijack your account and begins to do something. So it's not best practice that you expose it. So when pushing them when working on with Terraform, do not push your your provider.tl files, because provider.tl files is where your secret keys, your client secret, which is the password, your subscription ID, your tenant ID are stored. So it is not advisable that you push that to a public repository. So now in this place, we are going to see how you can create a service principal to be used. So to create a service principal, you need to run the SZ first to authenticate your login to Microsoft Azure. I'm using a CLI command in this case. If you want to use PowerShell, you can as well use PowerShell connect dash SZ account. Then you now connect. But this one, I'm going to run the SZ login and press enter. It will open up a browser for me to sign in. I'm going to sign in now. So I'm going to pick an account that I know I want to use. So that will sign in. I will go back to my command line. I'll go back to my command prompt interface. And while in this command line interface, I will just run, let it come up. So as soon as it's finished the login, it's going to bring up an interface listing all your subscriptions available. So what you need to do is that I will clear my screen to decongest the screen. So I'm going to create a service principal with a command SZAD. That is SZAD, that is Active Directory. Service principal is represented as AD. Then we are creating a contributor role. Contributor role will have access to be able to create, deploy Terraform as infrastructure within your environment. RBS is role-based access control. I will now contributor. So the role is a contributor role. So now scope it to your subscription level. Each of the roles is scoped to. If you have many subscriptions, you need to choose one that you're going to use for this purpose. Subscription, then you put your subscription ID. In this case, I'm not going to put my subscription ID because it's not meant for public. So you have to take note, do not expose some of these secrets to public. So I'm just saying, if you want to create, if you are creating alongside with me, so this is the run. And once you do that, you're going to have your app ID, you're going to have your display name. You also going to have a password. App ID is the client ID. Remember, you're not going to list it in your provider.tf file as app ID. You're going to list it as client ID. Then the password will be your client secret. Your tenant, of course, is your Azure tenant. Your tenant ID, that's your enterprise ID. Once you sign up for Microsoft Azure account for your business or for your organization, you are going to have what is called tenant ID. It is assigned to you by default. Once you go to Microsoft Entra ID, from this Entra ID dashboard, you should be able to see your tenant ID. Your tenant ID remain your own. You do not expose it. It's one of the data that should be kept secret, not meant for public consumption. So I'm going to point it to you. This is my own tenant ID, so I'm going to leave this place now. So now you get that and also put it in your Terraform, in your .tf file. So now having created that, you have to pick some of the, if you create it, you have to the details. What will display here is going to be app ID, display name, password, and tenant. Then you pick them to your Terraform file. I have my Terraform file already. I've defined because of our time. I didn't want to keep us waiting. So in this case, I want to deploy this thing using script instead of Terraform extension. So you can use Terraform extension. So there's a script I've written here. This script is going to deploy, install the Terraform extension into my Azure pipelines. It's just going to do all the configuration that I want within the process. So now in my Terraform file, Terraform code, I've defined three three files. One is called main.tf. The main.tf contains the real stuff that I want to deploy. In this case, I want to deploy Azure Kubernetes Service. So this place now, I've defined all my resource that I want to do. I'm also defined a variable. The variable file relies on the main.tf files by defining all the variables that are going to be used within the main.tf file. Then this one, provider.tf, contains everything. As I was said before, this is where your service principal, those details you created using those code will be put. But I'm going to quickly leave that for security purposes. It's not advisable that you expose it. So after that, I just did the initialization. Then before now, I've already created my Azure DevOps organization. As I said before, I've created this, and I have my Azure repo. This repo now is a version control system, just as we have GitHub repository. So my code comes in here and stays. Now I have that. Let's see. I'm trying to open it to be able to display the code there. So what is happening? Okay, let me. Now, depending when that will open, let me go back here. For those of you just getting started with, if you are familiar with the way Git command is used, it's the way I've used here. So first of all, you need to initialize repository. You need to also you need to add your code by using the git add space dot. Now you're also going to commit that code, and then when you do that, you now add the remote origin, which you take from the Azure repo, and then everything will be pushed to your Azure repo environment where you can have access to. Now, another thing I want to point out, when you your Terraform to a public repo to commit the provider.tf, because provider.tf contain, you can just put the template file, but do not add your client ID as one of the best practices to protect your information from being tampered with. So you need to remove this and just push the empty template file to the public repository. If you want to do it, you want to push it, that repository must be private, that only you have access to it. Now I've done that. So now in this place, I have my pipeline file that will run this, my YAML pipeline.yaml file, tf pipeline.yaml. So in this place, I'm going to supply my client ID as a variable here. I'm going to also supply my client Azure tenant ID. That this will make Terraform to recognize that this thing is to be deployed in my environment, to be deployed to my own environment, not any other person's own, or to a particular subscription, because you can create service principal for each of your subscriptions, depending on which one you want to. If you have up to 5 subscriptions, you can create for each of them, depending on which one you want to deploy your resource to. Now we have that. Another one is, okay, let me check my environment to see. Okay, now this stuff came in some 49 minutes ago, which I committed from my own IDE right here. So what I'm going to do at this point, I'm going to go to, let's take a moment to explore Azure DevOps component. Now, for proper collaboration when it comes to software development or anything you're doing, Azure DevOps is one of the best platform to use. Now we have, in this place, we have repository. Repo is the short name for repository. It is where it serves as a source code directory where your source code are installed. You can set up a build from here, or I do not want to go through here to set up the build. Now, for those of you who are, if you have a project, now I want to bring in people that will have wikis. Wiki will explain what this project is all about, to give a brief explanation of what my project is all about. But I will add the description. Azure Board is for collaboration, monitoring task progress. When you started the task, we can add work item to show you the status of your project. When you start it, when it to be end, when it will end, the ones in progress, the one that are already been done by maybe Oluwadamilola has done one, and the one that is assigned to me. Mind you, this only project team can have access to work items within a project. It's adopt the agile Kanban process, project management methodology. You can easily track work item, which one has been done, which one has not been done with this Azure board. So it's a very good one for you to use. Can track backlogs, sprint, queries, and all that. Now, repo, as I explained before, you get your code installed. And pipelines is which is the key component of our discussion today, is what helps you to automate your build and deployment of CI/CD pipelines. So now, test plan is if you want to carry out testing within your environment. You can create several test plan, can get your progress report within when you run a test plan and all that. So Artifact is what is the actual software that you're deploying. It could be you're deploying an Ubuntu, you're deploying image. It could be you're deploying a Terraform code. Oh, my volume is out. Wow. Oh, I see. Apologies for that. So, Dami, can you confirm that my volume is fine now? Please, can you just come on board to confirm that? Hello, Dami, are you there? Okay, so I believe my volume is back. Apologies for that. So now we are going to let's jump right into the Azure Pipelines environment. So I have my Azure pipeline here. I already have my code, so I'm going to just create a pipeline. Pipelines are run on parallel costs. You need to pay. We have self-hosted and Microsoft hosted plans. So before doing this, I need to go check if I still have my subscription, because otherwise it will not run. It will report error. But I'm going to take us through the process in case I do not have any parallel jobs left. So let me go to my project, my organization, then go to billing. Under organization settings, I can easily check my to know if I have any. Okay. Okay. Let me check my parallel jobs. Okay. Let the billing finish loading here. So I do not have anyone. Okay, but I have 180 and 1,800 minutes free. Now let me see if I have exhausted. I think I've exhausted it, but let's try and see if my pipeline will run. If not, because to the process of doing it. Parallel jobs, what I'm trying to load. Okay. So in my hosted project, I don't have any parallel job left. I think I've used the two self-hosted. I created self-hosted. Do I have anyone? Free parallel jobs. I think I have one here under the subscription. So get one self-hosted. Okay, let me just try and see if it will work. Then let's go back to that project interface. Damn, can you confirm if my audio is fine now, please? Damn, is my audio fine? So now here right now. I'm going to go to create pipelines. Now, where do you have your code? Your source, your code is stored. Our code in this case is stored on Azure Repo. If you have it in Bitbucket, one of the version control system, so you have it in GitHub, you have it in GitHub Enterprise server somewhere, your on-premises server, or anywhere you can bring it from here. This uses what's it called? You use or utilizes on-premises server that you have. I think my internet is not strong. Let me see. So now I have my code in the Azure repo. I'm just going to select that. Now the project I have is test project, which has the code within. Now, am I going to use startup pipeline? I can click to show more, depending on what I want to do. Let me just use the startup pipeline, or I can use existing Azure pipelines YAML file in my own file, which I've already defined in this case. So I can specify the path. This is a path to my own pipeline. Remember, I have it already defined here in my code, this one. So that is exactly what I select. And the branch, I will leave it at master. I have just one branch. I will just continue. So it will load up that YAML file right away. And what I just need to do is to save. I can save and come back later, or I can just run immediately. Normally, if I have my parallel jobs, it should be able to run and be able to deploy this infrastructure that I want to deploy. So I need to first of all trigger the build based on the step I define on my YAML file, then before deploying it. So at this build stage, if there's any drift discovered within your code, it will throw an error and give you the opportunity to fix it before deploying. So this is one of the benefits of using Azure pipelines, CI/CD pipelines as a whole. So let's watch this and see if it will go through. If not, I want to see the report it will give. You can easily view changes, and okay, these are the changes I made before. So let's go back to the pipeline and monitor it. It has failed because if it succeeded, it will mark green here. Let's see the reason why it failed. Now, I do not have what I was telling you guys. I do not have any parallel jobs left, either from me or from Microsoft. So I've exhausted it. The simple process for you to deploy code. You can deploy it. This is also the same way to using Azure DevOps. And this is also the same way for you to do, even if no matter what you want to deploy, you can, as I said before, you can use a infrastructure as code deployed, both your server databases, your network, and you can deploy anything at all. Where you can go through. As I explained before, if you want to try out, maybe if you are signing up newly on Microsoft Azure, you might be given a parallel jobs. And once you once you finish your maybe 100 free minutes, you'll not be able to run again except you. If you have any question that I can easily attend to, I come to the end of this section, and if you have any question, you can reach out to me. WhatsApp number for those of you number. If you can explore the learning part of AZ400. That is actually DevOps course. DevOps AZ400 course is the one you give you more information and learn about Azure. Prepare you for the Azure DevOps exam. To have one of the you need to have an Azure administrator certification that's required to be able to get this. Another one for those who want to make solution here, Azure can also go here. This Azure CLI, what's it called? Azure CLI. Now the AZ400 exam prep, you can go to this link, and order. So, Damilola, over to you. I'm done with my section. Thank you for having me. Dami, I think you are. So, pending when Dami will come. This section is powered by the Microsoft Azure community. Our aim is to empower young people and to ensure that you have the right tools to perform your job optimally and to stand out in this ever-changing tech landscape. So Damilola, I'm done, so you can take over. Thank you.
Yeah, thanks, Mr. Imo. Thanks for that session. Thanks for the clarity and also even taking time to walk us through a practical session. Thank you so much. If you have any questions, please feel free to reach out to us on LinkedIn or even on the WhatsApp group, and we'll be happy to answer you. And we'll still continue the DevOps session again from next week. So please feel free to join and to learn. Thank you so much for joining the session today. Wish you a wonderful weekend. Bye. Thank you, Mr. Imo.
Yeah, bye.